Hello everyone. Welcome to another session on Quant. Today we are going to talk about base concepts. So we have done number systems in detail and we have covered all the concepts, solved almost 4 dedicated session on number system problems. So to wrap it up, there are one area which is similar to number system but not directly tagged to number system is base concept. So it's an extension of number system you can think of, and we'll just cover the concepts today and follow up with one session on problems should suffice. So let's see. So this is one of the area which we need to understand a little bit, because we are not completely accustomed on solving number system like this or solving problems in this scenario. So what is base concept? So base concept basically talks about the different bases that we use for numbers. So what do you mean by bases? So by base I mean the numbers that a particular system has. So what I mean by that is we normally have digits 0 to 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 10 digits. So this is called as a decimal system, and this is most widely used base system. So a decimal system will have 0 to 9 as number. So it depends on the number of digits or the number of elements that system has. It has a name. Now we all know computer does not understand 0 to 9. Computer understands only 0 and 1. So then that is called as a binary system, because there are only two elements, 0 and 1. Okay. Now if I talk you about a octal system, octal system means there will be 8 elements. So 0 to 7, 0, 1, 2, 3, 4, 5, 6, 7. So that is called as an octal system. We primarily deal with a decimal system, and that's where the 99% of our problem hovers, and most of your problem in your CAT will be based on decimal system numbers only. But there will be certain problems specifically on base concepts. How you understand changing bases is a very lucrative area for CAT. We have seen historically 1 or 2 questions coming out of that area. So let's dive in a little more and understand this base concepts, how to convert from decimal to binary, binary to octal and others. And then we'll see how to do conversion as well as addition, subtraction kind of a thing. So that way we can understand how to basically write the how to do all these operations in a different base system when it is not decimal. We all know it in decimal. So if it is only decimal, we don't need to understand the base concept separately, but the idea is it has to go beyond decimal. So then there are another 2 key base systems, that is hexadecimal. Basically then 0 to 9, there are 10 of them, and A, B, C, D, E, F. So these are 5. So basically 0 to 9 is 10 of them. Then 10 normally denoted as A, 11 as B, 12 as C, 13 as D, 14 as E, and 15 as F. So these are the 16 elements, 0 to 15, 16 elements. That's why it's called as a hexadecimal. Okay. Sometimes you can think of duodecimal, which is 0 to 9 and then A and B. So there will be depends on the how many elements it has. If it is has more than 10 elements, then from after 9 it starts with the alphabets A, B, C, D, E, F. Depends on how many you have. If you have 11 elements to it, then 10 and 11 will be 0 to 9 and then A, B. Okay, so that's how we write it. So now the other part, also one more thing to understand, it the base is also nothing but the positional value. So positional value, I mean, if in a decimal if I write 3, 2, 1, right? If I write 3, 2, 1, this 1 is nothing but 1 into 10 to the power 0. This 2 is nothing but 2 into 10 to the power 1. This 3 is nothing but 3 into 10 square. So starting from 10 to the power 0, because it's decimal, the power of this value is basically the decimal base. So from decimal, I can say this is the place where we are using the decimal at the base. So 1 into base to the power 0, then 2 into base to the power 1, 3 into base to the power 2. So basically 3 is in the hundredth place. It is getting multiplied with base to the power 2. Okay, and this is what makes it 300 plus 20 plus 1, 321. So it also about the positional value of a system. So when I say uh, similarly 529, so it will be in decimal. So normally a base system is noted like this, a suffix after the bracket. So that means 5 into 10 square plus 2 into 10 to the power 1 plus 9 into 10 to the power 0. So that makes it 529. Okay, now if I write you 63 base 7, that means I have to write 3 into 7 to the power 0 plus 6 into 7 to the power 1. Okay, that's how we write it. So this is what is normally denoted as writing from a base system. What is the positional value of each digit means. So so basically, then if I have to write it in a generic format, then a number in base system n, let's say small n, base system small n, can be written in decimal as, let's say the number is n, let's say the number is capital N, a0 into n to the power 0 plus a1 into the power 1, a2 n square, a3 n cube, n to the power n. So it's so on. So basically, what I'm trying to say is, so this normally, if I write this 63 holes, 63 in base 7, if I write this, this will become 42 here plus 3 here. So 45, 63 base 7 is same as 45 in base 10. So this is the next part. What we want to learn is how to convert from any system to a decimal system. And this is the generic formula for this. Any number in any base system can be written as written like this to convert it into a decimal system. And we all know the calculation around decimal system. So from any base system to decimal is basically a very, very useful or a handy approach you should understand. So let's try it with one. Let's say I have 3AB. I have 3AB in base system 16. How I can write this as a number in decimal system? What in decimal system converts to 3AB in hexadecimal system? 16 means hexadecimal system. So I will use this. So my first is basically b into 16 to the power 0 plus a into 16 to the power 1 plus 3 into 16 square. Now, if I go back, what is my b? If I have in here, what is my b? B is 11 and a is 10. So I can write this as 11 into 16 to the power 0, 10 into 16 to the power 1 plus 3 into 16 square. I can write this as 11 plus 160 plus 256 into 3. 256 into 3, 768. Okay, 768 plus 171. So we can write this as 9, 938. 938 base system 10 and converts into 3AB in base system 16. So this is the most common way, and this is the most common format of writing a number from any non-decimal base system to decimal base system. So now you can understand how to write from any base system to decimal, right? Any base system to decimal. So let's take another example. Let's say I have 1 0 1 1 0 in this. So how will I write this? So I'll start first with this 0. So 0 into 2 to the power 0 plus 1 into 2 to the power 1 plus 1 into 2 square. So this one has taken care, plus 0 into 2 cube plus 1 into 2 to the power 4. So the first one will be 0, the second one will be 2, the next one will be 4, 0 plus 16. So answer is 22 in base 10. So now you understand how to convert any base system to decimal, right? So this 2 is nothing but coming from because of this 2. Okay, and start from the rightmost and keep writing, keep adding. So this is how to convert any base system to decimal. Now let's see how to convert a decimal to any other base system. So I will, let's say, give you this. Let's do decimal to other base system. Decimal to other base system. So how will I do that? Let's say I have given you 129 base 10. Can you tell me what is it in base 7? So this is the other way. From any base system to decimal we have seen. From decimal to any other base system is what we are going to see now. So the idea here is, since we are doing a multiplication and addition here we'll do subtraction. Division. So if 7 is my base, so I'll start with 7, start dividing 129. Okay. So if I start doing 7 divided by 129, this 7 1 the 7, 5 9, 7 8 is 56. So I have 3 as my denominator, remainder that I wrote here, 3. Then again I will do with 7. So I'll get 2, 7 2 is 14, and 4 as my remainder. I'll keep it aside. Okay, now I can't do further because 2 as my quotient, so I cannot divide it with further with 7. So this is less than 7. So I'll stop here. My number in base system 7 will start from 2 and go up 243. So my number in base system is 2437. If you want to check this, so you know how to convert 243 in base 7 to a decimal system. Let's do that. So 243 in base system 7 should be same as 3 into 7 to the power 0, 4 into 7 to the power 1 plus 2 into 7 square. So the first one is 3, next one is 28, the last one is 98. 49 into 2, 98. Together they form 129 base 10. You see, we can actually prove we are doing it right. So 243 in base 7 converts to 129 in base 10. Similarly, 129 in base 10 converts to 243 in base 7. Okay, so this is how you can do it. This is a part of division. Let's do it for a binary, and then I'll do one for hexadecimal. So let's say I have 29 in base 10. I have to find out what it is in binary. So I'll start dividing 2 by 29. 14, 1 I get, 2, 7, 0 I get, 2, 3, 1 I get. Still not less than 2. So I can do it again. Now it is less than 2 and I have 1. So this will be starting from here, go up. So 1, 1, 1, 0, 1, this 2. Right? Similarly, if I have 357 or in base 10, what it is in base 16, right? So again, I start dividing by 16 by 357. So 16 to the 32, 3, 7, 16 to the 32. So 5 is my remainder. Again, I'll do with 6. 16 ones are 16, and I have 6 as a reminder. Now it cannot go any further, so it will be 165 in base 16. So that's how this is the most important part of your base system calculation, from a decimal to any given base system, and from any given base system to decimal. On the next part, if they ask for you any subtraction, addition, multiplication, anything, my only 2 cents is, rather than learning the addition, subtraction, multiplication of all the base systems, try only learn how to convert into a decimal, and from a decimal to that base system. So let's say I can give you a problem of 23 in base system 7 plus, let's say, 32 in base system 3, and tell me how it will be, what value it will be in base system 5. I can give you any random problem, right? So the idea here is to convert the problem into everything into base system 10, and from there you can do it. So for example, how will I do it? So this number is nothing but 3 into 7 to the power 0, 2 into 7 to the power 1. This is in base system 10. Plus this is 2 into 3 to the power 0 plus 3 into 2 to the power 1. Again in base system 10. So this is nothing but 3 plus 4, 14. So 17 in base system 10. And this is 2 plus 6 in base system 10. 17 plus 6 is basically 23 in base system 10. Now you know 23 in base system 10, you have to see what it is in base system 5. So start dividing by 5, 4, 3. So this means it will be 43 in base system 5. So there is, even if there are multiple base systems given in the same order, let's say 23 in base 7 and 32 in again base 7, and asking what is the value in base 7. So the idea here is, even if the addition, subtraction are all in the same base system, there is no point learning the addition, subtraction of defined base system. It's the most prudent way is to convert that all the base systems into a decimal, do the operation, addition, multiplication, subtraction, division, whatever you want to do that, get the final value in decimal base system, and then convert back to the base system that has been asked in the question. That's the most prudent way of doing it. Okay. So this is all about how to handle base systems in a very effective way. So this is a short session. Just wanted to cover your understandings of different base systems and how to convert them and how to work with. There is no fixed set of numbers that numbers can only be from binary, octal, decimal, hexadecimal only. It can be anything. You just need to know the basic nuance of how to write any given base system into decimal, and given if you know the decimal, how to convert into any given base system. So that's the idea, that's the concept I want to impart on you in this session. And in the next session, we will deep dive, solve few problems, see few exceptional cases in base system, and do some CAT problems in that, and then we will wrap this session. So hope this session was helpful, a short and crisp session on base system. Hope you had a good learning. See you next time. Thank you.